Cool. I think everyone's here, and we'll probably have more participants joining us as we go. Ren, do you want to get started with uh, our sponsor message, I guess?
Sure, sounds good. I will quickly share my screen. Before that, I would I'm sure. Hey everyone, my name is Yuan, and I'm a co-founder and head coach of X-Camp. It's really a great pleasure to be here today to join the IOI events. Three of the IOI medalists today have been X-Camp students for several years. It's a great pleasure for the whole coaching team of X-Camp to be able to teach them and coach them. And we've been having lots of collaboration with CPI for the past several years. Even some of the core members of CPI are ex-camp alumni. So we are very happy to collaborate here to support the community. And today I will have a few slides to share with everyone. Uh, can everyone see my screen? Yeah, Ryan, can you see my screen?
Yeah.
Cool. Yeah, so I will first play a quick video.
Computer science and artificial intelligence are the tools that will shape the future. XCamp Academy is a community dedicated to inspiring and cultivating the next generation of computer science and AI talent. XCamp Academy, founded in August 2017 in Silicon Valley by two Google software engineers, XCamp takes its name from the variable X, representing unlimited possibilities and opportunities. XCamp's curriculum and training methodology are based on the teaching philosophy of Mr. Xianyou Xu, a Chinese diamond-level international gold medal coach. Our US teaching team is primarily composed of senior software engineers from leading Silicon Valley tech companies and top computer science students from prestigious universities. We're also proud to have the strong support of international and domestic competition winners who serve as mentors and coaches. From beginner level Python to advanced C++ and competitive programming courses, XCamp offers a structured curriculum designed to support students at every level of their learning journey. Through team-based competitions and collaborative group study sessions, XCamp fosters a spirit of cooperation and builds each student's confidence in their ability to code. As of mid-2025, more than 400 XCamp students have advanced to the USICO Silver Division or higher, including 75 in Platinum and 41 selected for the US and Canadian national training camps. Among them, 14 were newly qualified in the 2025 season, and 3 XCamp students earned places on the US national team, making up 3/4 of the entire team. In renowned high school contests such as Stanford's Procl, UC Berkeley's Calico, the Harvard Programming Invitational, and Teams Code, XCamp students have grown from participants to problem writers and contest organizers. Our students have received 18 MIT offers, along with many more admissions from Stanford, Harvard, CMU, and UC campuses, a testament to their hard work and excellence. At XCamp, we believe every student has unlimited potential, and our mission is to empower them to shine in the AI era.
Okay, a little bit more about myself. I have been working at Google for like 8.5 years on large-scale data infrastructure. And I taught and coached the first three batch of students at Xcamp. And once they reached Platinum, I built a team of many other teachers and coach, including Jing Bang, Ziyi, Max, and Arwen, Ce, and many other coaches altogether. They are mostly past IOI medalists, NOI medalists, and also USICO finalists, and also ICPC were finalists. Altogether, we help students at this camp to coach students in competitive programming. And in the highest level of X-Camp class is called the Grandmaster. And we have really good results for the past several years, including 41 finalists, 4 EGOI medalists, 4 IOI medalists, and many more lower level results as well. And one of the very precious memory in X-Camp history was that Kang Yang was my dad's student. He represented the Chinese team last year, and Brian represents the US team last year, and they won the first place and the third place last year in the IOI Egypt. When I look at Kang Yang standing in the in a stage, I didn't feel that much because that's not very related to me. But when I saw Brian standing there all together with Jingbang at that moment, we feel really, really proud and very, very accomplished because Brian achieved what we couldn't as teacher, as coach back then when we were students. That's, I think, part of the meaning of coaching. And a little bit about X-Camp before we get started with the IOI events. X-Camp is basically a school-style place that values serious STEM education. We are also very specialized in competitive programming education in general. We not just want to lift you to be top competitive programmer, but also we would really want to help students in their long-run growth. For example, research and internship even after they graduate from X-Camp. Right now, we have two very, very related competition-related program running. One is called Grandmaster, is where we cultivate finalists, platinum students, and IOI medalists. And the other one is called Candidate Master. It's new this year. I'm trying to rebuild the in-person style of coaching and teaching every single on a weekly basis. Basically, this is what it's like. This photo was taken actually last weekend. We start to have these kind of in-person discussion and coaching every single week. We have coach in Silicon Valley, in the Bay Area, and also in Seattle. In the future, we will build this in the East Coast as well. Essentially, it's very classic coach versus the apprentice, that kind of a relationship built starting from 6th grade or maybe even 7th grade. That's how we built X-Camp to begin with when I was a coach teaching and coaching every single week. That's something we are doing right now. And meanwhile, we are actively looking for coach and lecturers for summer camp, winter camp, and also for the candidate master program as well. And note that I'm not simply looking for top problem solver, but also or slice reader. But essentially, I'm looking for someone who loves coaching, who loves to help other people to grow. Just like how we coach our current students, we hope we have new coach we can grow in the system and help more students. And the Grandmaster and Candidate Master program will continue to run both online and in person. Currently, it's only in Seattle and Bay Area for in-person format. Join us if you don't want to do competitive programming on a whim. And also, I'm looking for those who are forced into competitive programming. I hope you love it and you want to do it, so you want to join. And also, these days, I start to help more and more people to get you connected with AI startup, sorry, this is not huge funds, it's a hedge fund, and also big tech companies as well, and also good university labs. Of course, I would give high priority to those who were past X-Camp students and also who I know in person, because that's just I will have some checking records to refer to or prove the ownership, or maybe you're good in something to me, and then I can pretty much refer you to almost all the opportunities that you might want to go. And also, we have the in-person winter camp incoming in the Bay Area. It's from December 26th to December 30th. And we have ICPC World Finalists and also Grandmaster coach teaching in person. If you want intense camp experience, by the way, that's the best format, I think. Ideally, we should all do it in person and in a camp style. If you're interested, feel free to email me, or you can also Discord me at burrito_play_violin. Burrito is my dog's name. She's a cute Shiba Inu. That's all for now, and I will turn to Ryan.
Cool. Yeah. Thanks, Ren. Uh, I guess yeah, welcome everybody to the CPI and X-Camp collaboration hosted IOI workshop. We're very fortunate to have like 3 IOI team members here with us today. I guess we can just go around and each give like a self introduction, I suppose. So I guess I'll start. I'm Ryan. Uh, I'm the director of workshops at CPI, and I have some like competitive hurling experience. As maybe we can go in alphabetical order. So like Alex can go next.
Okay, I'm Alex. I have some competitive programming experience. All right, yes.
Wait,
What else do I have
surely
to
like
talk about?
I guess like Brian then.
Okay, bye.
All right, I'm Brian. I'm currently a freshman at MIT studying, I suppose you can guess, computer science. Um, I suppose I started competitive programming in around 6th grade. I took like a 3-year hiatus and started again around in the tail of 8th grade. I also have a competitive math background. I've been competing for a really long time.
Okay, yeah. Hey guys, my name's Dawn. I'm also a freshman at MIT, also studying CS. I used to volunteer at CPI as like a USCO guide project manager. And yeah, I'm very excited to do this workshop.
Cool. Yeah. So we'll be opening up a live Q&A later on, but first we sort of have a like a small contest for uh our IOI team members to do just to sort of like um I don't know, like start the workshop and have something to talk about. Um I think the problems should not be too hard. Um and I think it's actually started already. Uh, so I'll like share a screen of each of each of their windows, and we can just sort of start that. Um, wait, do you guys know if it's scheduled for? Wait, yeah, it starts in I think 1 minute. Um, let me share screen, and cool. Are you guys ready on your ends to like to take the contest?
Yeah, I'm good.
Okay. Scary. Need more scrap paper.
Wait, let me actually make it so that other people can like solve along with you guys. That may make it more interesting, I suppose. Maybe if you win, like you'll make it to the IOI team next year.
Yeah. 3, 2, 1, go.
All right. I guess the contest
What
started.
the heck?
We can just like start on, I guess like
Right, problem 1. Okay. Filter R, define the maximum. Okay.
yeah. So I guess
So
any
the
contest like this.
maximum is just the maximum element.
Oh, we have an early submission. Hi, Dawn. Um. Oh, and I think you got it right. Very strong performance there. Oh, Alex is coding, and I'm assuming that means that Brian has solved this as well.
Oh,
Okay, we have very fast ACs from all three participants. For the viewers, if you're interested in the problem, pretty much you're just asked to find the maximum value of the average of a subarray in a single array, and one observation is like this subarray can like be length 1, so it is optimal to take the length 1 element, and that is sort of what each participant put it up, I hope. Yeah, where they just output the max of each of the array. Yeah, that looks correct. Yeah, I think we'll be going to prompt 2 now. It's currently a very close race between all three competitors. Dawn looks like he has a solution right now. And Brian does as well. For those of you following along at home, problem 2 is sort of just is a task where given two integers, you want to you want to convert one integer into another integer by XORing the original integer with something less with another value that is less than the integer you have right now. And you have a limit of 100 operations to do this. Let's see what our competitors come up with to attack this problem.
But we should be muted.
Can I? Right, Brian looks like he's like debugging now, I guess. Um, Dong seems to have like a solution and is submitting. And yeah, he does get AC first. So very strong performance from Dong right now, getting both first ACs. I guess I'll wait for all the other competitors to solve the problem before sort of going over the solution to this. And Alex Chen seems to be making some substantial edits to his approach right now. As you can see on his screen, he currently has a function called high bit, which goes to show that even in IOI, you don't really need to have that good of a hold on this C++ syntax, I suppose. But let's see if anybody has, let's see if anybody else has AC'd. Oh, I see. Brian has AC'd as well. I think Alex Chen is writing like a very short solution right now, and it does look to be somewhat correct. Let's see if he can like cut the nuances. Meanwhile, for those watching at home, I suppose we can start talking about problem C, which is another constructive problem, but I suppose the previous problem cannot really be called truly constructive. in this problem, you need to find out, you're given a tree, you want to construct a tree such that the product of each, the vertices at each edge, is a perfect, is a perfect square, or like, sorry, the sum of all these products is a perfect square. Let's see if our competitors can solve this just as quickly as they solved the other problems. Alex Chen seems to be doing some debugging right now on his end. It seems Brian already has a solution while uh, oh, while Dong is still trying to work out the samples, work out the sample cases. Uh, it looks like Brian is hard coding one of the samples, which may or may not be interesting strategy, I suppose. Dong appears to be working something out on paper, and Alex Chen is finally submitting. So let's see if this code does in fact work. Let's see. Where are the standings? Let's see. Okay, so now all participants have solved the first two problems. For a solution to B, uh, the key observation is to realize the highest bit, that A's highest bit cannot exceed that of its original, and it's not hard to, and after that is satisfied, you can just it's not hard to construct a sequence to lead to B uh, through, I think, like XORing like A, X, or B with, sorry, or by first turning all the bits on is one approach, and then um, just XORing the bits that are not part of B. It appears that Brian has written some code, but it consists of hard coding the n equals 5 and n equals 2 and n equals 3 sample cases, which perhaps this is part of some strategy, or perhaps this is like uh, a key observation. If any participants in the workshop want to follow along and try to solve the problems on their own, I think this is a Codeforces. These problems are pulled from a Codeforces Div 3 round, and you should just be able to find it by like searching a beautiful tree. Oh, we see our first submission from Brian here. Oh, strong, strong. And Brian is the first to hear the contest, it seems. I guess we can like look at the other streams, but it seems that neither has begun like coding a solution yet. Wait, Brian, do you want to unmute and like talk about the first two problems in the meantime?
So I'd like to mention number one is a very popular problem, it seems, because I originally set a harder version for a contest I ran at my school, and then someone else asked me it in the MIT cafeteria like a few weeks ago as well. So
Wait, does this imply that MIT students like cannot take the max element of an array or?
no, I think the person who thought of it thought it was funny, and then he like made it harder with a few modifications. I mean,
Oh, I see, I see.
it was an interesting problem, I think, at the end. Sorry, I'm
Uh,
a bit
uh,
sick right now. But yeah, I mean, so I've seen it, so I don't really think anything I say can count for how to solve it. But if it's a div 2a, generally the coding work is gonna be very light.
Wait, it's like div
Yeah.
3, so
Oh wait,
not even
oh,
div
div,
2.
div 3a, coding is probably very light. I mean, it's kind of hard to explain like the back intuition. I think for me, it personally comes from like Jensen's inequality and like what convex functions are like. But like, I think this is just a question that like is so like classic that I can't explain how I solved it.
I see.
But
Wait, you're talking about problem 1 right now, right?
yeah, I
Or
can talk about problem two, I think, which is I think is a little bit more interesting. Um, so problem two is kind of messy. You don't want to deal with like picking a random number less or equal to a. Like it's kind of hard to check if if you can get like a specific number less or equal to a. So your goal is just to like get to a place where everything's very simple, like as fast as possible. Because you're given 100 operations, you're not forced to do the minimum. So this gives you the idea that you have to like just find something that works very easily. So, I mean, like if you want to first think about what numbers can very easily reach other numbers, or like, okay, sorry. So like, I guess the first thing I thought of was how can you check if two numbers are reachable? One very simple like thing you can notice is that um, if you can only sort of have like the bits that are on in A are only bits that are lesser or equal to the initial value of A, if that makes sense. Like let's say I have some 2 to the k, where for some positive integer k, where 2 to the k is greater than the initial value of a, I can never get the kth bit on in my like in like my current value of a because like I just don't have the sort of utility to get there. It's like outside of my range. So it's like once you have this, you realize that you want to work with um I'm sorry. My brain's kind of cooked right now, but wait, am I rambling?
wait, it's like fine.
Okay, wait. Okay. Yes, rumors. Yeah. Okay. So once you have this sort of guess condition where it's like two, some A can reach B if and only if like A sort of is big enough that it can eventually reach every bit in B. Um, you want to get to a point where you want to think about what A's can very easily reach all B's that have like the bits that are very easily accessible, if that makes sense. So it's like if you think about like 2 to the n minus 1, 2 to the n minus 1 can very easily go to anything from 0 to 2 to the n minus 1 because you can quite literally just enumerate the bits. I mean, and once you have the idea of trying to get to 2 to the n minus 1 because you can go to 2 you can go from 2 to the n minus 1 to anywhere else, like the problem is relatively just like plug and chug. Sorry.
Indeed, that is a correct solution. It seems that Alex Chen has an idea for the constructive of uh C. But Dong has not begun coding it, I suppose. But okay. Alex has currently written the code to loop through the test cases, which is indeed like quite important for the problem, I suppose. I guess for the audience to follow along better, I can probably just explain C one more time. If Coach Roses will let me. So in problem C, pretty much we want to construct a tree that satisfies this condition called being beautiful, where if we take the sum of the products of the endpoints of each edge, and we want this to become a perfect square. And for some like sample inputs, um, and for some sample inputs, we have stuff here where it's like uh, this is a beautiful tree because 2 times 3 plus 1 times 3 is 9, which is a perfect square. And this is also a beautiful tree because 4 plus 2 plus 3 is also 9, which is still a perfect square. Oh, it seems that Dong has also started to solve the problem, I guess. Wait, it seems like it is still B though, which is, or, okay. Wait, wait, Brian, what are your thoughts on like giving a small hint to uh the others to make us go a bit faster?
Should I? Consider what you get from the simplest star graph and try to turn that into something that works.
Oh, wait, what again?
So consider the star graph 1, 2, 1, 3, dot, dot, dot to 1n. So
1,
this
2.
achieves a sum of like n times n plus 1 over 2 minus 1, right?
Wait, what? 1, 2, 1, 3. What? Oh, yeah. Okay.
So try to turn this into a construction that does work.
Like,
Okay, wait, I'm curious, do any audience members have ideas to solve this problem? Now, maybe one of your only chances to like prove you're smarter than a IOI team member, I suppose. Um, uh, wait, I guess maybe I can give like, or maybe I can like repeat like a hint that I was trying. Oh yeah, I can send a link to the problem. Uh, let me find it, and I think it's this one. Yeah. Um, yeah. I guess I can take this time to like repeat like a subtle hint I was trying to like give earlier, which is that Brian's code involved like hard coding the first 5 things, but afterwards it was like not hard coded, which may be of use. Wait, Brian, sorry for like uh bugging you so much, but I guess to fill the silence, I know you like just came from Meta Hacker Cup, so how did that go?
It didn't go well.
I
I
see.
don't want to talk about it.
Yeah, that is unfortunate.
Debugging is too difficult.
Um, I think just maybe at like 1:45, I'll probably like just cut the contest off just because we don't want this to take too much of the time. Um, oh, it seems that Alex Chen has written something. Uh, I think there's a syntax error there, but oh wait, no, there is a minus sign. Something different from Brian's solution is that he appears to have hard-coded everything up to n equals 6, which uh, I don't know. We'll see how his construction goes for him. Long also seems to have, oh, that's just like cutting the previous thing. Uh, I guess like this will be the last like 3 minutes of the contest. Um, it seems that Alex Chen is trying to solve the case for n is equal to 6 right now. Um, and is this construction correct? It seems to be different from Brian's actually. But I do think there should be multiple solutions to this problem, so. Okay, it seems that we have the beginnings of the solution by Dong. Yeah, I suppose in retrospect, when choosing problems for this workshop, I may have underestimated the difficulty of constructive problems. Uh, let's see if Alex Chen has made any progress in that time. He appears to have started the case for n equals 6. And he's checking if the calculation is correct right now. Oh, unfortunate. That is apparently not a perfect square. Oh, but that is. So I guess Alex Chen will now attempt to submit, although I'll allow this submission from Alex, and then we'll probably end the contest there. Shoot. Oh, and it seems that Alex has solved it.
Yeah, we did it.
Uh, oh, yeah, sure. I guess,
That was hard. Putting it back
yeah,
ahead.
I guess, we can sort of like start the Q&A now. We'll start by just by talking about the contest. Um, but then, but then like we'll just talk about like more topics afterwards. Um, I guess I'll just start with Dong. Like, uh, what like thoughts did you have when you were looking at this problem at first, out of curiosity?
Um, okay, so I'm kind of like bad at constructors, but I'll like try to explain my thought process, which didn't really get anywhere. Wait, so initially I thought about like trying to connect everything to one node. Like basically like a star graph. Um, and that didn't really work. Um, and then yeah, and then like I tried to like print some things out, which also didn't work. And then Brian gave the hint, which I guess is like pretty useful. Basically um, like from Brian's hint, like the construction is probably like having a star graph with one in the middle, and then like alternate, and then like changing one edge. So you kind of want to like connect two nodes, like X and Y, and then like disconnect one of them uh from node one. Um, and I tried to like work out the algebra and I couldn't. So yeah.
Oh, I see. But I feel like that's like very nearly to like the full solution. So I guess maybe like a few more minutes. Uh, Alex, I noticed like you solved it like almost last minute.
Oh,
Do you want to go over the solution to this problem?
all right. So, uh,
I can just pull up your stream, I suppose.
okay. So, yeah, you want to make the center of the star two. Since you make the center one, then you get like n times n plus one over two, and that over two is not conducive to squares. So you want to get n times n plus one, and then and after some calculation, you can get that if you just did the star, you would get n squared plus n minus 4. So you want to remove n minus 4 from the star. And to do that, you want to take the n minus 4 node and attach it to 1 instead. And that solves the general case. And in this specific case, you kind of just bash out from the examples.
But I'm curious, does n equals 6 like not work for the construction or
Huh?
Wait, is there a reason you coded for n equals 2?
Because n over 6, I think. Wait, let me think. Oh, 2 is used as the center of the star graph, right? So
Yeah.
you can't really use that.
Okay.
You can't really attach 2 to a 1 and then decrease.
But yeah, also like if you're any chat member, any like audience members, like please feel free to like start sending questions at this time, and we'll try to address like as many as you can, whether about like these problems or just like in general for the IOI team. And feel free to like direct message me as well if you want to stay anonymous, I guess. And then I think Brian, you had like maybe a different solution to this problem.
I mean, yeah, I think again, it's the same idea of like you don't want to intentionally make the problem too complicated. So if you just start with some like simple construction, just like like 1 to 2, 1 to 3, so on, like the star graph, you notice that you immediately get a construction for n squared plus n over 2 minus 1. So you notice like this looks extremely similar. Like the goal of the problem is essentially to manipulate this quantity into like a polynomial that you know is a perfect square, because this is the only way you can really get a general construction. So, I mean, you don't want to think too much, so let's just try to turn this into n squared. So it'd be nice if I could just like double this so that it'd be like I get rid of the 1/2 and just gives like n squared plus n. So then I just like move 2 to be the center of the tree instead of 1. And then, this construction gives like some weird quantity like n squared minus n minus 4, I think. And then at this point, so you need a, or no, n squared, sorry, n squared plus n over 2. Or you have something that's like n squared plus n minus something. So now you need to get rid of the n. And the easiest way to do this is like to just like disconnect the 2 to n edge and replace it with the 1 to n edge. So like the idea is you just keep making very small modifications to the graph that subtly change like the total sum in a way that like makes the total sum something you want. And like each individual change is like very simple. You just need to like think a little bit. You just need to like keep like chugging through it, I guess. And
Uh,
you get a simple construction in the end.
cool. Yeah. Um, I guess we'll just like start with like some audience Q&A now. I guess the first question is, uh, what are your tips to get into IOI camp for this season, I suppose?
I don't know. Do well on the skill contest. Yes. Um,
Uh, do you guys have any other thoughts?
it's been so long since we did the contest. But yeah, usually solving one problem and getting a partial on the other for all the contests, you should be fine.
Yeah, I think adding on to that, it's like getting it's actually takes less points than you might think to qualify for USCO camp. So it's like a big part of it is just like getting every point that you should. Like some I know like sometimes you're like lazy, you don't want to implement like a 300 line bash with like some stupid data structure and like casework, written by yours truly Suhas Nagar, but like if you get 2 points, like you gotta take it. I mean I remember there was some problem on like a January contest. I was like some horrible DP on a cactus. Um, I didn't finish implementing that, but it was like an absolute slog. But I got like a decent amount of partial from like a slightly. Bro, I'm still mad about that. I had a 1 line bug in that solution too. It should have been full score, but like
Dang.
I was willing to implement it, even though I knew there was a very high chance I wouldn't finish in time, and there's a very high chance that I write this like 300 line casework garbage code and I get 0 points for it.
Dong, anything to add?
Yeah. So my usual strategy, like going into contest, is to like it's kind of like what Brian said, is like you want to maximize your score on every single problem. So like um so I guess like for example, like one strategy is that like you at the start of the contest you can like list out the subtasks and then I each like or like when you have time, then like you go through the subtasks and then like you pick which one to work on. And like this kind of like brings you this kind of like stops you from like spending too much time on like one problem, because like if you always like go back and like review like which subtasks like you have left and then like pick which one to approach, it'll probably like get you like points that you need for to kind of like maximize your score, like in a sense.
Cool. And I guess that kind of leads to like our next question, which is like, do you guys have any like contest strategies that you want to share, I suppose?
Mhm.
Or just like any like tips for approaching a contest?
Okay. I guess I'll add something. So, well, I guess like well, I guess like specifically for like the monthlies, like usually what you should do is probably like read every poem first, and then on the monthlies, like usually there's actually like one easier poem out of the three. And you should try to like and like ideally you want to like solve that problem in like maybe like the first hour or something. So
Just a side note, this is like for plat,
But
I
yeah,
guess.
finding it is potentially difficult. But yeah,
yeah, okay.
if you get one problem that you can solve, then you of course you should like solve it, I think. Like once
Yeah.
you're able to
Um
identify it and you have pretty good confidence that your solution actually
Wait,
works.
just to clarify, is this for like all divisions or for plat, I guess?
I guess for plat, I don't know,
um, yeah, this is specific for plat. But for like other divisions, usually the cutoff is like around like
two problems and a half.
750. Yeah, so like you want to because I'm pretty sure the subtasks aren't like that generous. So like you should also try to like aim for some full solves. Um and like what I recommend is probably uh like attack one problem, and then once you get that done, you're working on like a two problem contest, and that should hopefully be easier for you to like decide what to do.
Yeah, cool. Our next question is, at what grade did you guys start competitive programming? And I guess how were you introduced?
I don't know, six? Forgot.
Yeah, I suppose I already answered this question in my intro, but I've been doing competitive math for a long time, and I think competitive math shares a lot of skills with competitive programming. I find that a lot of people who end up making it to MOP especially can have like a skill set that's actually very transferable to coding. So originally I started math like I started competitive math when I was 6, but I started coding in C++, and this was like the first time I actually competitive coded. Like a family friend like tutored me a little bit, showed me like a few like 1300 code forces problems. That was in 6th grade. You know, I started like screwing around, just like taking contests. There was a very easy series of contests that year, so I would qualify for East Gold pretty early, but I was not good enough to actually be in East Gold at the time, so I kind of found it difficult to advance. I kind of soft quit for 3 years, but I would say I practiced very actively from this like the summer after 8th grade to sort of junior year, like the end of junior year.
I guess like, do you have any tips for anybody that's like starting Fisco then, or like should they like train math before or like?
Well,
Yeah,
but
I think there's a Code Forces post on this by like Geothermal or somebody where he says like you should do a bunch of like alchemist problems and math problems. I agree because I think the skill set you get from math is very important because I see like a non-trivial amount of people who can like who learn how to code without learning how to do math. And this is like I think a very bad idea because like learning math will help you with everything in your life. Like quite literally like everything I do in life, like math helps me at least a little bit. And I think I lost my train of thought, sorry. But just like I think you should learn math not just for competitive programming, but just because like it's quite useful for like anything you want to do. But yeah, I would highly recommend doing math first because just like you meet more people too. Like I think a big part of like what I've gotten from competitive programming, competitive math is the people I've met. And getting like your hand in like both communities is like pretty nice.
Okay. Yeah, I guess this is like a pretty commonly asked question, so I'll just like address it. Um, it's like how many hours like a week or like day or something do you spend like preparing, and like how do you balance that with like other activities in school and stuff?
right now, like not that much.
Or I guess the question's like
I
pertinent.
tend what
I guess the question's like pertinent towards like before IOI or like when you're
before.
preparing for that stuff.
I don't know. It might be 4 hours. So I'm not. I don't know how to count hours, unfortunately. Uh, but yeah.
I
Uh,
think I don't quite like this question because it's kind of like not the answer is not particularly useful to you, right? I
Yeah,
think
the answer is not going to be
because
particularly useful, I think.
like of course everyone has like varying levels of intelligence, especially in like different areas. Like I for one am horrible at relatively horrible at constructive problems to like my favorite DS problems. But like um I think like if you look at the people, they will tell you like very different experiences. Like I know people who spent like who do like an like an hour a day. I mean, you've seen like the tourist post where it says like, oh, he coded for like 2 hours a day, like no more than 2 hours every day, and now he's like number one in the world. And I think this is like a very different experience from what a lot of people might like expect. Like, if you want my answer, I can tell you I spent probably an average of like, I mean, during summer camp, I think in total probably like yeah, like 6-ish hours a day for like several years. But like I mean, you shouldn't really think about like as like a goal to hit where it's like, oh, I'll have to do this number of hours every day, right? Like I don't count like the time I spend in the shower like thinking about problems or just like when I'm walking around, I just like decide to think about something. Like I can't really like sum all of this like up into a single quantity. And like I think if you go into this thinking like, oh, I'm gonna spend 3 years, like I'm gonna spend like 5 hours every day, I'm gonna hit USCO Platinum, I'm gonna go to USCO Camp, like you will like maybe it'll work for you, but I find that this is like a very like sad way to go about it. I think it's just like you get burnout, man. Like I don't know what to say. I got hella burnout in like at like in like sophomore and junior year, but like you gotta find like your own way to sort of enjoy the process and like not think of it as like hours and think of it more as just like a hobby. It's just like something you do. Like do you count like, oh, I spend like 5 hours playing like Brawl Stars every day? Like I don't think this. I just think like, oh yeah, sometimes I like play some video games. There's like and like sometimes I competitive program. Sorry, that was a bit of a
Dong,
rant.
Dong,
Yeah, that's good wisdom.
anything to add or?
Yeah. Well, I kind of agree with Brian. Like, I think if you ask like UCCO campers, most of them will tell you like, I think like most of us just like genuinely just like love doing these contests and like we kind of like practice without like thinking too much about like how much time do I spend. Um, but like the result of like I guess like loving it so much is that you do end up like spending quite a lot of time. So like for me, probably also like um maybe like 5 hours per day when I was like training really hard. But like I think it's like looking at time is like not the right way of thinking about it.
Uh, yeah, I think our next question was just like, what was the most memorable experience you guys had at IOI?
Well, I think the time we played like a weird version of Mao, and eventually I got to come up with a rule. So my rule was counter. So I there were like 8 cups conveniently stacked next to like the game board, so I just laid them down, and then every time like somebody played a card, they have to like increment the counter by 1. That was really funny. No, I cannot marry you, E.
I see. So I guess just like the activities you did there. Uh, Dong, Brian.
I think probably my favorite memories are, I mean, for one, like there's this sort of like normal memory where it's like I'm just like playing card games with like some people from where like I think like 2 guys from China, another guy from some people from Canada, some people from Australia. Like I think occasionally, people from like everywhere would just like sub in, and it's just like really cool to like meet people and just like have fun with them because like they're actually like we're all quite similar, we like algorithms, we like difficult problems and so on. But I mean in general, I think the actual memory that just like is most stuck in my mind is 2024 Egypt taking the photo in front of the Sphinx with the teammates. Like there's like a certain high in that moment that like I can't describe, man. That was awesome. I don't know what to say. It was actually just an amazing feeling, just standing there, instead of this like massive, like giant thing, like like historical monument everyone knows about, and just like enjoying it with like the people around you.
Dawn?
Yeah, yeah, I think it was just like amazing to like, meet people from like other countries and like see and kind of like I mean of course like the like card games and whatever, but like also kind of just like learning, for example, like how they train for like computer programming. Because like we kind of like all come from like we all have like very like different experiences, and it was really interesting to like learn how they train and like how they think about things.
Yeah, cool. Uh, so I guess like a takeaway here is like, yeah, it's more about like the friends you make along the way. Maybe the real IOI was the friends you made along the way. Uh, our next question is, how have you like continued competitive programming in college, and has your experience like uh helped you in college at all?
Mhm. Yeah, I kind of continued a little bit. There's an organization called UTPC on my, and I just go to their weekly contests, go solve some problems, and just kind of just have fun, I guess. And I guess it has kind of helped with my courseware as well. Like a lot of this stuff, I kind of have a vague idea of like I have an idea of like I've most of the concepts that I kind of learned before, I guess. So I have a better understanding.
Yeah, I would agree with this experience. I mean, like at MIT, there's like a few levels of like algorithms classes. There's like the beginner one that like you're supposed to take immediately. Well, not immediately. Like it's considered a pretty difficult class. But I think most people who hit like UCICO Platinum or like have a lot of competitive programming background, just like find this class like they've learned most of it before. Like their brain has like all the intuition it needs to like solve all the problems in the class. They pretty much immediately skip to like the higher algorithms classes. And I mean, this is just like something that not a lot of people can do, you know. These are like hard classes. I mean, but just like the intuition you get from UCICO helps you. So like personally, I skipped ahead to like a grad level algorithms class where I actually get quite challenged. The lecturer is very good. Um, I think half my class is competitive programmers. I know on the first day of class, our lecturer mentioned how he received like many emails from various USCO campers and like IOI medalists about how they wanted to take his class and like how they haven't taken the prereqs, but they'd still like to take it. But I think competitive programming builds a lot of skills. I mean, and like another thing is like like sometimes I'm trying to get a job, man. Like I want money, but um like you get like online assessments where you have to solve a little coding problem. Like they're actually just like not hard, all right? I think for most people with a lot of competitive programming background. But yeah, like as for involvement, I do like MIT runs like an informatics tournament called MIT IT. I'm a problem setter.
Oh no.
We'll see if you get a taste of my problems sometime. You know,
Okay.
I hope to still be involved in USICO. Like I don't really compete or train actively. I just like when my friends gives me a problem, like I solve it. But like I'm tired. I've retired at this point, I think. Coding is hard, man. I never liked implementing problems. So like I just don't have really an incentive to keep practicing implementing, I guess. Which is a shame, but
See, but I think if any audience members want to like meet like Brian or something, I think like he said he'll be like a camp coach next year. So that's like extra motivation,
yeah,
trust.
I need to actually do work for USICO if I
Oh,
want
shoot.
to. And unfortunately, I have a problem set due this Tuesday that I should be doing right now, but
Oh no.
I
I
see.
have like two peer reviews to get to or something.
Dawn,
Like,
uh,
Yeah, yeah, so pretty much like start practicing like ever since college. I still do like contests. So I think I did like one versus contest and like 2 rounds of like meta hacker cup. Um and I guess like related activities I'm involved in like MIT IT, I'm building like the soft or like the website to like run the contest and like run solution codes and stuff. Yeah, and all three of us are also like helping prep musical problems. So yeah.
Cool. I think one question that I got is the like what you have sent is like what do you do when like you're faced with like a really hard problem to solve and like do you guys like give up on problems or like come back to them later or something like that?
I guess yeah, eventually if like there's like not you could like ask others, I guess, for ideas. I guess that's probably one of the ways. Or eventually if you're just doing it by yourself, you can look at like the first few lines of the editorial to get some headway and then try to solve the remaining problem from there.
Yeah, man, I don't know what to tell you. I just instantly fold, man. Like I don't have the brain power to think about a problem for too long. But
IOI third place, but by the way.
when I do decide to spend like longer on a problem, when I spend a lot of time, like ChatGPT is like a very useful assistant where I just like paste the editorial in without reading it and just like ask like give me a hint or something. But you know, I think you can solve a lot of problems like way above your level if you just like stow them away and like think about them like a little bit every day. Just because like I find that a lot of times when you get stuck, it's because like you get stuck in like a specific path of thinking, and just like a good night's rest can just like clear that away and make sure you actually get to like the right point. But I would say depending on the difficulty of the problem, I spend anywhere from like an hour to like several weeks like thinking about it. But I mean, sometimes like it also depends on the problem setters. Because there's like some problem setters where it's like a problem that you can solve and it's like motivated. If you like think about it hard enough, you can like sort of like get to the solution eventually by just like thinking about like what might work, what doesn't work, like just like what you need and like very simple questions. But there's also problem setters who write problems that are very unmotivated and that it's hard to think of a solution. So in that case, that also plays a factor into whether or not I instantly read the editorial or not.
I see. Dom?
Oh yeah. So yeah, so I think like um usually I'm like probably like a bit impatient. So like if I like can't solve a problem for like an hour, I'll probably just like read the editorial. Um I also think like personally I guess like I sort of like developed like maybe like some like intuition on like whether I can like solve a problem or not. And so maybe I have like a feeling that like I can probably solve it and then I'll like work on it for longer. And then otherwise I might just like read the editorial. I don't think that's like best practice though. I guess like what you usually want to do is like maybe if you can't solve it then like just go for a hint. Um yeah, I think like reading the editorial, kind of like, I guess like looking back, like maybe I shouldn't have like immediately like read that many editorials.
Cool. I think our next question you guys like sort of already answered, but it was asked anyway, so maybe we can just give like a quick answer. It's what do you do when you know the solution but the implementation is too hard or annoying?
Uh, if it's too hard or annoying to do in the contest, then I'm just gonna go for partials. Like in the if it's in the remaining time, like it would take if it would take 6 hours and I only have 5 hours left, then yeah, I'm gonna be kind of toast. But yeah, and I'll be or I'll be going to other problems and trying those as well.
Yeah,
But if it's just like I'm just solving it by myself, then yeah, there's no time limit. So yeah, just implement it and yeah.
I'm probably this is actually one of my bigger regrets, I guess, that a lot of problems I didn't implement. I might solve a lot of problems if I don't implement a lot of them, and because of that, my implementation skill is much lower than it should be. So like as for practice, I think you should always implement, or else you'll end up like me, where you have like three solutions and three was. Like this is not a good feeling, and I would encourage you to do your implementation to avoid that. But during a contest, I mean, it's kind of hard to describe this for me because the bulk of contests I take do not have any like major stakes. So like in a way, I'm very used to just like implementing it because if I can implement this, then it proves that like I'm good, right? Like I feel like I feel like a lot of the time it's only by implementing something really difficult in like a very short amount of time span that you can like really push yourself to improve your implementation skill a lot. So I think like during practice you should like almost always go for like the big thing. And I mean during contest I also implement the entire thing. But this is also the cause for like several of my very poor performances. So yeah, I would advise you to write partial if you're actually taking a contest.
Yeah, I think like implementing a solution always helps you, like at least for me, it helps me like remember the problem. So like I usually like during practice, I usually always like implement a solution if I have it. Or like maybe I read a tutorial and then I implement that solution. Um, I think it helps like with, I'm not sure how to describe it, but like I think like implementing it helps like you develop this like intuition for like solving problems. And like in a sense, like maybe I solve this problem and then if I read like some other like similar problem, I think it helps you kind of like, find the similar ideas and like and kind of like get you to like a right solution path. So yeah.
Yeah, so just like during practice, just like implement everything and then like take away and then like during contest like go for partial, but also like don't be afraid, I suppose. Yeah, our next question is do you have any like resources you would recommend to uh someone new, and like what advice would you give to yourself if you were starting competitive programming again?
CSAS maybe.
Yeah, I would concur with that. As for beginner resources, CSAS is one of the best ways to like get exposed to a lot of basic data structures, like well-known techniques, and like some just like basic intuitions that everyone should try to learn. Um, CPI and skill guide, of course. Like I started competitive programming before these were like sort of, I don't know if they were released yet. Maybe it was like
Well, there
at
was
the
the
very
useful
least.
training pages, which are like really
No,
old
no,
and
no, no,
sad.
no. No, no, don't do those. Don't do those.
I
He's
don't know.
he's trying to sabotage you. Don't do the East Coast training pages. Um, yeah, I really wish I had UCL guy when I was starting out. Like I sort of just, got some help from a family friend, but it would have been very difficult at the time, I think. So it's nice that these resources exist. I think you can get like a very sort of varied problem diet, like getting like a lot of different styles of problems, different ways of thinking by just going to a lot of different websites. I would recommend you definitely do Codeforces and ActCoder because I think ActCoder builds a lot of intuition that you can't, that like slogging through a bunch of Codeforces problems doesn't. Like you get a guarantee on the sort of quality and type of the problem if you do ActCoder. So I recommend going there. Wait, was there a second part of the question? I remember there was
Oh,
something
wait,
about resources and something else.
I think we'll like it was what advice would you give yourself if you're starting again? But we can just like do that after everyone answers like
I see. Of course.
the resources part.
Yeah, yeah, I also recommend Code Guide. I started off like when I started like coding, Code Guide didn't exist. So I did the Code training pages. Um but yeah, but like Code Guide is like a great resource. It's like updated by like many of like the top like competitive programmers. So like you kind of like get like an idea of like what things you should know and like there's like practice problems there too. So yeah, definitely check that out.
That's just as an aside because nobody mentioned this, but maybe you could look at other countries like national Olympiads. Uh, yeah. Yeah, I guess yeah, the other question I sort of asked was if you were starting competitive programming again, what advice would you give yourself?
I guess I'll try to answer this question
Sure.
first. I think I would tell myself find some friends for the love of God. Get some friends who also do competitive programming. I think it's very hard to do competitive programming by yourself. Like if I actually look at sort of my like skill, like my skill over time graph, the time I fastest improved was during like sort of 8th grade, 9th grade when I was going to X-Camp. I was quite like I went to in-person camps and I was surrounded by like 10 people who were all like my friends. Like, I can like probably walk down the hall and like find them like in the lounge or something. But like they're generally just like some of the best friends I've ever had, and like being friends with them in the context of competitive programming, like it just motivated me to do it so much more. Like there's a bit of competitive spirit, like you want to like solve problems your friends can't, and like and sort of like like flex on them. But I think just having community helps like a ton. I mean, part of the reason why like I quit like math originally and was because like I just like didn't have anyone. I was doing problems pretty much by myself, and like it gets tiring, man. Like after the fifth, after like the 20th geometry bash that you fail, or like the eighth, like you've been debugging it for 3 hours. Like you don't want to do it anymore. It's not fun.
Yeah, yeah, I guess like one advice I would give to myself is probably like learn a bit more math. Because I like started like competitive programming without like much like competitive math background. Like, if you compare like fifth grade me versus like fifth grade Alex and Brian, I'm definitely like much worse. But yeah, so I think like I think yeah, so Ryan sent like geothermal's like blog. I think like I think like something along like that line of like training of like having like a good like mathematical understanding of like some things is like pretty important. So yeah, I definitely would recommend that.
Alex, did you have anything to add or?
Not really. I guess maybe one thing I might do is maybe like respect my coding style to be more suited to competitive programming. I mean, but I'm not sure. Like since I still like bin power recursively, which is kind of awful, but yeah.
I think there's a question earlier that I missed actually. And on the receiving side of this, I'm like curious too. It's how do you guys work together in team contests? Well,
Oh, I see ideas. Oh,
Wait, also like
uh,
also to the audience, just to note, like IOI is an individual contest, even though like they're the IOI team, but they also do
so
like
yeah, we do
contests.
do team
Yeah.
competitions. I don't know, like having a variety of skill sets in the team, like Lunchbox can usually destroy any DS problem. Perhaps, yeah, and yeah, having a variety of skill sets helps like the team like cover more problems.
Yeah, I think this is a bit of a harder question to answer because, okay, so first of all, I want to preface this by saying I haven't practiced for team contests. I haven't like taken that many team contests. But I mean, for like most high school style team contests, things like Calico or like Proco or like BAPSI, I think all of these where you have 3 computers, it's quite literally a big part of it is just getting 3 people who are all very good at coding and all have like have like a decent sort of space spanned by their like collective skill sets. I don't think there's that much strategy there. I like part of it is also recognizing when you need to like quit a problem and let someone else go in, or like just like knowing who's good at what problem. Like I can just like yeah, like, as Alex said, if I see a data structure problem, I just call Lunchbox, like I call Dong in for like a data structure airstrike, and bang, it's gone. But I think for like ICPC style contests, which is like the bigger like college competition where you only have 1 computer for all 3 members, I don't have that much experience in this. I've had the privilege of like sorry, of getting to practice with like some really good people. And generally the consensus is like again, everything else holds. You need like the people need to be strong themselves. They need to have like a variety of skill sets. But for ICPC specifically, um, you need to be really good at implementation because if you're sitting on the computer for 2 hours trying to debug your data structure bash, that's 2 hours your teammates can't be coding and 2 hours of problems that your team's not going to get. You should only code like once you should only code once you know the full solution. I mean, yeah, I don't know that much about team contests.
Mhm.
Yeah, I don't know, man.
Oh, I remember like after like one of our trainings for ICPC, when my teammates suggested like I write the solution on paper or like doing it on the computer, and like that allows usage of like paper time, which you have like 10 hours effectively of to like make the computer time like use more efficient.
Dong, maybe like the data structure air structure can like give some
Oh,
thoughts as well.
yeah. Wait. So I guess like for ICPC, as like Alex said, it's pretty common to like maybe like print out code and like debug on paper. But I guess like I'll speak more about like high school contests. Because like Alex, Brian, and I did a lot of those together. Um, for me, like those contests were probably like one of like the highlights of like one of the highlights of like competitive programming contests. Like I think like going to those contests, especially like in person, is like very fun. Um, it might be similar to like math contests. I'm not sure because I didn't do much of those. But yeah, but I think it's like very fun. Um, I guess like it's like really exciting like seeing your teammates like solve problems. And it's like, and for me, I guess like the highlights for me are like, me reading some like math or like geo bash problem and like handing it off to my teammates. So yeah.
I guess like the conclusions here, like have good teammates and like they can do like different problems. Yeah. I guess we're like reaching the end, so this would be like the last two or three questions. Um, I think if I didn't get to any like audience members' questions, it's probably because they were like too specific and like something like uh what is it like I'm in this scenario and what should I do, which is probably not very good for the workshop. Yeah. I think our next question, probably second to last, is what is like a big misconception about competitive programming that you think exists? Uh, and you think you should clear up, or do those exist at all?
I guess I remember like doing what in math contest, and like I think Richard Russell talked about like for I had like this skit where he had like this big formula sheet, and then like it ended up like being useless or something, and he like threw it in the air or something. But yeah, I just like in math, how like sure knowing formulas could be good, but like knowing how they're derived is like better, I guess. And yeah, and usually you don't like it's better to know how to like apply the formulas in like creative ways rather than to just know a bunch of formulas and not be able to use any of them. And this is analogous in competitive programming. If you know FFT, if you know like link country, but you cannot do anything with them during contests, then they're kind of not very useful.
Uh, any other
But yeah,
questions?
if so, it's better to like know a lot of the basics first before you learn the more complicated algorithms. Like as Omnic said, stop learning useless algorithms.
Yeah, I think I'm gonna give another like friends we made along the way thing here. I think a lot of people go into competitive programming with one of a few mentalities. I think one of the biggest, like the foremost ones is, especially for high schoolers, is I'm gonna make USCO camp. I'm gonna go to MIT. This is true, or like I'm gonna go to like maybe not MIT, but like I'm gonna go to a very very good college because of this, right? And I claim like this is like partly true, okay? Like the USCO camp is a very big feeder. People like appreciate this a lot. Or like another one's like, okay, I'm gonna do competitive programming. I'm gonna become a LeetCode demon. Like every online assessment is gonna be trivial to me now. But I think the biggest thing competitive programming like the biggest things competitive programming have done for me are like, for one, it's given me a lot of confidence in like myself and like my sort of abilities. my ability to work with other people. But like I think the biggest thing is just like the people I know. It's like it's not just like the friends we made along the way. It's like I show up to my interview for a job and like I find out my interviewer is a competitive programmer. Like my and then like I go to another job interview. My competitive sorry, my interview is a competitive programmer again. I like look down the hallway. I see at least like three competitive programmers who are like if I want to connect to like it's really easy. You know, we have like all this shared background. We have a lot of things to talk about. We can complain about like Naurus together. That was a bit. Um, like I just like think that some of the greatest utility is just like I know so many people now. It's awesome. You know, I need a referral. I just like DM, you know, like one of my youth skill camp coaches or like someone else I met through competitive programming. And just like you get a lot of utility outside of like just college apps, you know, that you don't really expect that early on. I don't know. This is a bit of a rant.
Yeah, I agree with what Brian said. It definitely goes beyond college apps. For me, I think it like in general it helps like a lot with problem solving. Like, I think it's pretty hard to describe, but like I guess like for some people like like competitive programming skills like map to like math skills. I think it probably like helps me in the way that I like think about problems. And I think I really appreciate like the time I spend competitive programming that like helped me develop these like problem solving skills. So yeah.
Cool. Yeah. And I guess just like one last question to end it off, like as the Yusuko, like as the next season is like approaching, um, and like people want to like do well, presumably, what's like a concrete step you would like advise people to like just like do for getting better at competitive programming, like right after the workshop? And is there just like any general advice you would leave them with, aside from like making friends that do competitive programming, I guess.
Okay. I'll say like uh okay, so the contest is in like probably a month, like roughly a month from now. I guess like in general, like you should probably make, I mean, yeah, you should probably make sure that like you know like roughly what's going to like appear or like what type of problems are going to appear. So like maybe go on to like musical guide, just like go through like every topic in your division um and then like see if you like know the topic, if you don't know too much, and then you can like kind of like adjust like how you can like plan for like practicing problems like eSchool Guide also has like a lot of practice problems within each like module. So I think like just making sure like you understand like what type of things could appear on the contest is like pretty useful.
I think I'm gonna hit you guys with something else kind of. Oh wait, Alex, do you want to go first? Or wait, Andrew.
Wait, is there a,
Wait, sorry.
there seems to be a bit of an echo.
Yeah,
I'm not sure if that's a...
me and Tong are actually in the same room. We
Oh,
were kind of roommates actually, but I'm gonna hit you with another cheesy sort of answer to this, which is like you should take care of yourself. I think one of the worst failures I've ever had in competitive programming, like I knew it was gonna happen the night before. Like I was quite literally unable to sleep like the night before. Like I don't know if it was like stress or just like the environment, but like I think like it's the worst feeling in the world when you spend so much time preparing and like optimizing your performance and like you know you can do it, except like something stupid like your body like fails you or something. Like you should try to eat healthy. You should like get enough sleep. I think that's a big one. Um, you should try to increase your general quality of life. I think the happier you are, the faster you tend to improve as well. And it's also, of course, easier to have motivation. But like, just like make sure you get enough sleep the 2 weeks before, man. Like, I know there's like sometimes I remember like in ninth grade, I think I was playing like I think I was playing Genshin Impact for like until like 4 in the morning, for like the entire week before the contest. That contest didn't go well for me. Yeah, I don't know what to say.
Alex, any like last words you want to give to
I guess like preparing for the contest, like you could probably like yeah, I guess solve problems, but I guess perhaps in the coming days, like before for the contest, as you may also think it's like better to like take rest and like make your general quality of like better, I guess, in the time before the contest. Oh.
No, cool. That's pretty much it for our workshop. Make sure to check out like make sure to check out like X-Camp classes because several of the people who have like been talking in the workshop have been like X-Camp students. And also like check out CPI and like our classes and like the use code guide and stuff. If you have like any more questions, like you can like DM me on Discord and like I'll try to get them answered. But hopefully they're not like super like specific. Um, I think yeah, many of the resources that they mentioned are like linked in this chat and like are pretty easy to find. Yeah, thanks everybody for attending our workshop. Um, Good luck on the East Coast season. Yeah.
Okay.